Welcome. In this video I talk about structs and methods. Structs and methods are similar to C++ and classes, but not identical. In particular, Rust doesn't implement normal object-oriented and design and inheritance, but does things slightly differently. In this video I will cover structs and normal methods. I will cover traits, which is similar to inheritance, later. We start with a simple example of a struct. Here you can see the definition of a struct. It's struct S, then in curly brackets, the components with their type separated by commas. Notice that you can use a closing comma here for uniformity. We will talk about public and private fields later. For now, they are private. Here you can see how I define a struct with the literal struct syntax. I just use the name of the struct, again curly brackets, and specify all the components. You cannot easily print a struct right away with curly brackets here, but you have to make sure that the language derives code for debug printing. With this directive here, just in front of the struct, you can ask for automatically derived debug code, which then enables you to use this : syntax to print a struct as such. Let me run this. So the struct with the debug syntax is printed here as curly braces and then the components. And here I accessed the members of this as you know them in C++. Before we move on with methods, I want to show you some curious special cases, namely tuple structs. You don't have to name the attributes of a tuple or of a struct. You can just use a tuple instead. So if you use round brackets for the definition of the struct, you just give a list of types separated by commas, and then this is a tuple struct. You access the components with .0 and .1 and so on, and they have the corresponding types, and in all other ways this just behaves like a normal struct. You can derive debug and use it in the same way with the same similar syntax. A very special case is that if the tuple has no entries, that is an empty struct, which you also can define like this. Let me see what that does. So the syntax is similar to what you write in the program. You can access the components, and the empty struct is just printed with its type name. Let's now talk about methods. If you have defined a struct, and I'm using my original struct with the two components here, with derived debug information, then you can specify an impl block for it, an implementation block, and just mention normal functions here. These are then the methods which are implemented for the struct S. Notice that I can have methods which don't name S amongst their arguments, except maybe for the return type. So this is a kind of constructor. You can hint in an integer and a string reference, and it constructs such a struct and returns it, again, move semantics by default. That is, of course, why we have to call toString here, which copies the string and the string reference, and the string slice, such that it has its own allocation, and then we can stick it into this struct here. That means also the construction here of the name attribute uses move by default. There's a special syntactic sugar here. If you have an argument which is called self, then it means that this is the recipient of the method. That means the show function here is not called standalone, like here, the constructor, but it's called with a dot notation on an object of the type struct S. The first argument here can be called reference to self. Then it's an immutable reference, so this method only has immutable access to the attributes. Whereas this here, with this syntax, has a mutable reference and can therefore modify components. And we'll talk about private and public later, but the methods, of course, have access to the private fields of the struct. Let me try to run this. And indeed, we can construct the thing. And if you look at what we did here, the ID is incremented by 1. We have defined it to be 1 here. We have incremented it here and then showed it. And indeed, the output shows 2 here. We are now finally getting to public and private. I've modified the program slightly by using a module. This is something we will cover later in more detail, but suffice to say that I have defined a submodule here and put the complete definition of the struct and its methods in the module. Outside, I can use it by just qualifying the name of the struct with m::, the name of the module, and then ::. However, for this to work, I would have to give the public keyword here and for the methods. Let me show what happens if I remove this pub here. Then immediately it tells me that S is a private definition, so therefore I cannot use its name outside. So let me put the pub back here. If I remove the pub here, I get a different problem. Namely, the function new is private. The method for this struct is private, and therefore I cannot use it outside of the module. The same is true for the dot notation. If I remove the public here, I cannot call public show because the function is private. And finally, the attributes are private by default. So therefore, I can no longer use direct member access to access the fields, because now the field is private. I could make this public by giving the keyword pub here. And then this would compile. So let's see how this runs. Indeed, everything works. And here we now have one public and one private field, and we can only access the public one outside the module. Right, that's it for this video. We have talked about structs, tuple structs, have mentioned methods and public and private, and we have even seen our first module in action. That's it for today. Thanks for watching. I hope you enjoyed the video.